We have studied earlier and we have seen that the maximum chain is a chain which has the maximum weight among the all possible chains. And now we have assuming that the interval between these chains are positive and the value will be W is greater than 0. Now the problem is the axon changing problem, and the problem statement is that given a set of putative axon, as we have already detected through various techniques, statistical and the similarity approach, we will find a maximum set of non-overlapping putative axons. And we have already seen that the target is to isolate and identify out of these putative axons the only axons that are non-overlapping. So because we are using the algorithm, the input will be a set of weight intervals, that is putative axons, and as an output we will get a maximum chain of intervals from this set. So from these weighted intervals, putative axon, we will get the intervals from this set. So the axon changing problem for n intervals can be solved by dynamic programming in a graph G on 2n vertices, n of which represent starting from the left side of the intervals and n of which represent ending on the right side. We assume that the set of left and right interval ends is sorted into increasing order, that all positions are distinct, forming an ordered array or matrix. In this, the vertices will be starting from V1 up to the V2n in a graph that is we designated as G. So there are 3n minus 1 edges in this graph. So there is an edge between L1 and R1. L1 means starting from left and R means that ending at the right, of weight Wi for I, that is from 1 to n, and from 2n to minus 1. So these additional edges of weight will simply connect the adjacent vertices. So here in the diagram we can see that this is the L1 and this is the R1 of the weight W1, and that is for I is 1 to n. And the weight 0, we can see here we have added 0 that simply connect one vertex to the other. So these are vertices, they are connected with each other, and we can see here the weight is 0 for each of the edges that connects the two vertices. So at the end we will get the 0 weight which simply connects the adjacent vertices, that will be V1 up to the V1 plus 1, and that forming a path in a graph from V1 to V2n.